Okay. We should be live.
Perfect.
Okay. And we are okay. Hey everyone.
Hey everyone.
Ready to start.
Welcome to the FuseML community meeting, everyone. Let's give it a couple more minutes. Maybe there are people joining late, and then we can start.
Don't forget, in the meantime, to visit our GitHub Repo. And of course, to add a start to our project. Okay, I will say that we can start. This will be anyway recorded, so we can go there. Stefan, I will say that up to you.
Thank you. Let's roll it.
Okay, cool.
Okay, here we go. So welcome again to our FuseML community meeting. This is so the main topic on the agenda is, of course, the recent FuseML 0.2 release and everything that all the goodness that comes with it. Let me present the agenda at a length, and then we can dive into the individual topics here. First of all, my name is Stefan. I'm one of the project founders, and I have in the call with me Jerzy, Flavio, and Alessandro, the other project founders and members. Today's agenda is mainly focused around this new release, 0.2 FuseML. We'll start by showing you a few architectural changes that we did in this release. We removed components that were no longer required with FuseML. We replaced some built-in components with what we think are better components that are better suited for FuseML. We're going to detail on exactly what happened there. Next, and maybe the most important thing that we did in this release is something called FuseML extensions. And in this release, it's really focused around making FuseML really easy to work with from the point of view of adding support for new third-party machine learning tools. So it's all focused around facilitating the integration and also the installation of third-party tools through FuseML. So we understand that one of the features that people like most about FuseML is how easy it is to use it, to use the installer, to install not only the built-in components, but also to facilitate the installation of external tools, external machine learning tools like FuseML, like MLflow and KF serving and so on. Even though that is not the central focus of the project, we do acknowledge that that is something really nice to have, and it's really useful to be able to deploy an entire stack of AI/ML tools through FuseML and then use those tools to automate MLOps workflows. So we focused on that in this release. Most of the changes, most of the features are in that category. We extended the way that you can interact through the installer to install external services, external applications. There's also something that we introduce in this release, something called an extension registry that makes it that basically decouples the FuseML workflows themselves from the from the third-party machine learning tools that are used as components in the workflows, and that allows you to configure workflows that are reusable, that are portable, and overall it gives a better experience with FuseML workflows. Another feature that we add in this release is something that we we've waited a long time to complete, and that is to have persistent storage for the FuseML core service state. Now, let me explain quickly what that means. Previously, the information that was stored in the core service, so things like workflows and workflow associations and applications, they were stored in memory. That basically meant that if something happened to the core service, to the core pod, so accidental crashes or maybe even intentional shutdowns, that state was not preserved. That state would be lost, and that was, um, well, to say the least, it was an inconvenience. And in this release, we persist that state in persistent storage. We save that state in persistent storage. That means that you can safely reboot, restart the core service pod, and it also allows us to perform other operations such as upgrading the FuseML core service without losing that state. Last thing on the agenda, if time permits, we can show you a few tips and tricks around how to handle code sets, projects, and users through the FuseML CLI. So that is basically what we want to walk you through today. Again, we're really excited to have you here. And without further ado, let's dive into it. Let's go in the first topic with the architectural changes. But before I do that, we want to make this experience more interactive, so it won't be just us relaying information out to you. There's a chat in YouTube if you're watching this through YouTube. I encourage you to use that to pose questions anytime you feel like you have something to ask, and we'll be closely monitoring that and taking short breaks between these topics in the agenda. Look for questions and try to answer them as timely and accurately as possible. Having said that, let's look at what architectural changes we bring in this new release, and I'll pass it on to Flavio to tell you more about that.
Hello, hi everyone. So my name is Flavio. Thank you, Stefan, for the introduction. I'll be talking a little bit about some enhancements and improvements that we did for version 0.2 of FuseML. So let's start with Docker registry. FuseML started as a fork of the Carrier project, now named Epinio. And with that, we inherited some of the service that we use. One of them is Docker registry. So Carrier had this kind of customized deployment of Docker registry, which was dependent on Quarks. For FuseML 0.2, we were able to replace that Docker registry with throw, which is a registry implementation that's supposed to run on Kubernetes. It's more lightweight and also includes support for auditing and airbag and so on. It's a well-maintained project, and we are deploying throw using its Helm chart, which with minor modifications from upstream, so it would be easier for us to maintain that. So with that, we were able to remove Quarks. Quarks was basically used to generate secrets and certificates for Docker registry, and it is kind of not so easy to get it deployed. There are some dependencies, even for Rancher, you need kind of some additional configuration. So we decided to remove that and just use throw for Docker registry, which is more simple and easier to deploy. Besides that, we also did some improvement on the ML flow builder. So before FuseML 0.2, every time you run the workflow, the builder step, the example workflow that we have, on the builder step, it builds an image with all the requirements for doing the training of the model. In FuseML 0.2, we are able to reuse that image. So supposing that you run the workflow, the image was built the first time and you didn't change the requirements. The next time you run this same workflow, if the requirement didn't change, you see that it will run faster because you don't need to build the image again. Also, it does not consume much storage as building the image every time and storing it on the registry. To show that, I have this FuseML deployment here. I already did some workflow runs. I have 4 workflow runs here. One is using sklearn, the other one is a TensorFlow run. And if we look at this first run here, we can see that on the builders tab, it tries to look for the image. It sees that the image is not registered on the FuseML registry. Then it goes on and build that image before doing the training. And let's take a look on another run. So this is a second run of the same workflow. So we didn't change any requirement. So you see that on the builder tab, it finds out that this image already exists, so it will not build it, and we'll just reuse that on the training step. Here you can see that, so first run took 4 minutes. To build the image probably took around 3 minutes. And so the second run is faster, just took 1 minute to run the same workflow a second time. So it will be faster to rerun your model, see if it's fitting what you are looking for, and so on. And so that's basically some of the enhancements that, well, the main enhancements that we did for FuseML 0.2. And with that, I'll pass it back to Stefan.
That's great. Thank you. Thank you, Flavio. So one thing that we should probably also mention is with this new release, we updated all the built-in components as well as the external machine learning tools that we integrate with, so MLflow, Kev serving, and so on, to their latest version. So you get access to the latest and greatest tools you can work with for your machine learning purposes. Checking the chat for any questions. None so far. All right, so I guess we can continue to the next topic in the agenda. Let me share the agenda back to you. Next comes the what I like to think of as the star of this show, FuseML extensions. And this is basically split into 2 categories, features that you can think of as mapping to the usual workflow that one goes through when using FuseML. So you usually start by installing third-party tools, maybe on your own, maybe through the FuseML installer to give you a better experience and less friction on installing machine learning tools that you want to integrate with FuseML workflows. That would be the first step. Next step is to reference those tools, to actually use those tools and services in the MLOps automated workflows that can be orchestrated by FuseML. Based on that 2-stage approach, we are adding, in this new release, we're adding extensions, extensibility to the installer to help you, well, first of all, to help us add support for more, easily add support for more tools, to install them through the FuseML installer. But also we're introducing this concept named extension registry. And that's what I want to talk to you in more detail about. The extension registry, you can think of it as a place where we store information in FuseML about describing the third-party, the external machine learning tools that you want to integrate with FuseML. And this information is focused around what product they belong to, what services they provide, how those services can be accessed, so through URLs, through configuration that the client needs to have set locally to have access to those services, and more. So, for example, we also took into consideration the aspect of authentication and authorization. If you need to configure specific credentials to access those services, then you can do that through the extension registry. And because all that information is located in one place, in one component that is completely separate from the workflows, then the workflows can simply reference a set of extensions, those set of extensions in the registry, in the extension registry, that they need to consume to do their work. So that decoupling allows for more flexibility in the way that you define the stack of AML tools that you want to integrate with FuseML, and also flexibility in the way that workflows are using those tools. And I guess I can show you what that looks like through the CLI quickly for one of the FuseML installations that I have running locally. You get something like this. So you get a list of extensions that I have currently registered with FuseML. You can see that KF serving, for example, is one, MLflow is another, and what information is exactly stored in this registry? Well, aside from some obvious things like an identifier, the product that is actually running externally, and a version, every entry here is basically an installation of some product, one instance of said product, one instance of MLflow in this particular example. And every instance can provide several services. And that's the way we thought of this model that maps really well to all the Kubernetes applications that we are currently installing and using with FuseML and its workflows. Basically, a service can correspond to a Kubernetes service, and the way to expose a service is through an ingress or a similar thing that is an endpoint. So you can see that this is a generic way of describing any application, any service, any platform, framework that is running in not only in Kubernetes, but more generally anywhere. And it's really flexible to express what such a tool represents and configure it in FuseML, in the FuseML extension registry. There's also credentials, as I mentioned. If any of these services, external services, needs authentication and authorization, you can configure and set explicit credentials to be used in your workflows. There's even scoping involved, although currently we only have global scoping supported. We're thinking of adding in future releases support for scoping credentials to projects and even users. So that's at a glance what this looks like now. I can show you in more detail the MLflow extension, how it is represented internally. As I mentioned, the MLflow extension is providing two services, at least in our interpretation. It's providing an experiment tracking service, which you see here, with its own endpoints and configuration. It's also providing a model store backed by an S3 storage service that you see here. And these can be accessed independently in workflows. So if you only need to access the backend store, and we'll see exactly how that is useful in a few seconds, then you only reference this service in your workflow. If you need both, you can reference both. Configuration here, at least, covers the credentials, and as you can see, you can configure the this is another feature that the extension registry provides. All your sensitive data can go in here. So users, passwords, credentials, keys, you save them in here, and they're only accessible through the workflow where you need them to be accessible. They won't be visible anywhere else. To give you a more relevant understanding of how the extension registry is used in a workflow, I can show exactly how this we have a workflow, an end-to-end workflow involving MLflow and KF serving as the tools that we integrate with, featuring as an example in our example repository. And this is exactly it. And what this page shows you is how it changed after the introduction of this extension registry feature. Now, previously, in the trainer step, so the trainer step is about training a machine learning model. It's quite obvious. But in this particular case, we need access to MLflow as an external tool. And the way we the way we made that connection, the only way you could make that connection was through the workflow itself. So we had to hard code all this information about how the external tool, MLflow in this case, can be accessed. So endpoints, URLs, even credentials, which was not only an inconvenience, but also not secure. Everything needed to go in the workflow. Now, with the introduction of the extension registry, you can simply reference the extensions on extension entry in the registry itself. And in this particular case, you can see here, I'm referencing the experiment tracking service and the backend S3 store, both coming from MLflow. So I'm targeting specifically the MLflow product here. And I need both services to train the model, because the model will go in the S3 store and the tracking service will be used to track the metadata, the metrics, everything that comes out of the training process itself. Furthermore, the same thing happens with the predictor step, in this case, KF serving. Previously, I had to hard code here the credentials. With the introduction of the extension registry, now what I'm doing here is first of all, I'm referencing KF serving as a requirement, because I need KF serving to run in the cluster to be able to create these serving inference services through the predictor step. But what I'm also doing is I'm referencing S3 as a service. Any S3 service will do. In this case, this will match to the MLflow S3 backend. And everything else is happening automatically. All the credentials are being injected, all the configuration is being injected automatically into the machine learning, the container images that are running the machine learning steps. So it's everything automatically happens now. And I hope that covers briefly, but at a sufficient detail, how this new extension registry works. There's a second aspect to FuseML extensions, as I mentioned, and that pertains to how we install third-party tools through the FuseML installer easily, so without having to change the code base. And that's what Yeji will be explaining in more detail. Let's see. Before we do that, let's see if there are questions. No. I'm not seeing any questions. So Yeji, mic is yours.
Thank you, Stefan. Hi, so my name is Yeji, and I'd like to talk about another part of the extensions, another aspect, and that is how to actually install them using the FuseML installer. So, as Stefan just shown you, we have this extension registry where you have this very rich options of defining all the data, all the keys, all the values regarding certain extension. Like for example, I'm showing here how the ML flow extension is described in YAML file, and it is a lot of information, right? So you can use this command line command that Stefan was showing to register such extension and provide all these data that is shown here. But it could be done. It could be quite difficult for many, and frankly not necessary. So what we did, we actually extended our FuseML installer to give us support here. So if you remember how the FuseML is installed, FuseML is installed using another command line. It is called installer, and the installer takes your Kubernetes cluster and installs all necessary components of FuseML into that cluster. In previous version, this included the base components like Gitistore and Tecton, and also the ML related components like MLflow or KF serving. We've actually decided to split those ML parts from the base parts, and those ML parts are actually that's what we call the extensions. So right now you can still use the install command, and you can pass the extensions option and list all the extensions you want to install into your cluster. But even nicer way to handle the extensions, even like distinctly from the main installation, is actually using the extensions subcommand of the installer. So extensions really handles the extensions that are A, installed, and B, registered. Installed into your Kubernetes cluster and registered in your extensions registry. So let's take a look, right? So let's try the list command. It tells me I do not have any extensions here. Installer tells me. Now this is the same thing what actually the FuseML would tell me, right? This is the command Stefan was using, and this is the command that you could use to register all those extensions using those complicated YAML files. You could provide all these informations and register some external tool. But let's use the installer, right? This is about the installer. So what you can do here is add the extension using add command, and yeah, let's add MLflow extension. Now, yeah, you can see some basic debugging information here. Well, meanwhile, let's take a look at the output of the help command. You can see that one option was add. That basically means add, install new extension. Obviously, remove is another one. And what is nice is this extension repository option. I will talk about it shortly. Right now, you can see that our MLflow extension has been installed, and it tells us where is it accessible. And yep, that's it. Now, when we take a look, list command, it tells us it is indeed installed. We can even check what FuseML says about such extension, and FuseML could get us much more information about all the information that was added here as a MLflow, right? So this is basically the same as you've seen in the YAML file, right? But right now you can see that this is already stored somewhere. FuseML already knows about all those information. This was added by simple extension add command, right? So obviously another command is remove, and what else is? So you might ask, okay, this is interesting. You might ask, how does it know where to get such information? Well, this is really what this repository option is about. So extension repository, here you can provide the path to repository with all the extensions, right? And it is still taking those extensions from this repository. This repository is basically a directory. It can be a local directory. Let me show you, for example, like this is a directory for in my system, and we can install extension from local directory. So for example, here I'm installing Knative extension from the extension repository that points to the local directory in my file system. If we do the list again, we can see Knative is installed together with MLflow. Right? If, like in this example, if you do not provide any extension repository, what you get is FuseML installer will install it from the GitHub repository by default. That is part of our that you can find under our FuseML organization, and that is the extension repository. So browse to extension repository, and under the installer directory, you find all those extensions we have already prepared. So those are two, currently you can see those are two ML machine learning related extensions, MLflow and KF serving, and Knative Asserter Manager. They are basically just dependencies. So they are installed by KF serving itself. So let's take a look how it actually looks like, how what is hidden in those directories. And as I'm saying directories, this is the default directory on in GitHub Repo, or we can take a look at the directory that is which is local here in on my computer. This is the same content. So basically, each directory has one mandatory component that is the description file. In description file, you provide a description of the extension you want to install and the installation instruction. So for example, here is KF serving. There is some basic data, version and description, and install instruction and uninstall instruction. So for example, with customize type installation, you provide a location of a customized directory, and the user and the installer will use these instructions to actually install each step. There could be multiple steps for each extension. Let me show you some example with multiple steps. Knative, for example, right? So Knative has several steps for installation. It takes manifests. It's just a Kubernetes manifest file. Again, location points me to the YAML file, which is this Kubernetes manifest. It does this installation step by step. So there are 2-3 manifest steps. There could be even some wait for sequence. So after the step is completed, installer waits until certain condition is met, and there could be even the script option, which is basically a bash script that is located. Again, there is where the location option points to. So for example, there is no absolute URL here. That means this script is located in the same directory as the description file is. You can see is just a bash script which does some magic after the installation. So that's Knative. Another option is Helm chart, right? So type Helm, basically a Helm chart that is for MLflow. MLflow is installed using the Helm chart that is located at this address. It is uninstalled the same way. So that's as I said, because you can pass the path to the repository with the installer command, like here. That basically means you can edit, you can create your own extension description. Just create the local directory and experiment, right? We have cert manager here. We have some description file. we have some and create your own install steps pointing to specific locations, and that's the way you'd add your own extension and let it consume by FuseML installer. Just one more thing I wanted to show is this part actually. Yeah, the last part. So again, I'm switching to the original extension description that Stefan was showing. And you have seen, for example, there are some data like those AWS values, part of the credentials section. So this, for example, for MLflow, this is these are the credentials for the S3 store, for the Minio S3 store that is actually installed together with our MLflow chart. Now, we were not adding any keys like that in our installation file, right? But we've added a way how to extract them from specific Kubernetes objects. So that's why we have this service credentials section, which tells the installer where to get those specific values and how to add them when it is registering the extension. So here we need to fill the value of AWS Access Key ID, and we are telling the installer to look for the secret of this name in this namespace and for this specific value in the secret. Installer reads this and converts this information to the credentials information here in the registered extension. And as we were showing when checking the registered extensions, those would be the credentials that are actually hidden here. It won't show us these extensions. This is a feature, so they are not shown by default. But they are known. They are saved into extension repository, and when the workflow is run, FuseML knows which credentials to use. Okay, I think this is it for what I wanted to say about installing extensions. Well, in any case, if there are any questions, feel free to ask right now or in our Slack channel. Thank you. And I believe now it's time for Flavio to talk about persistent storage.
Okay, thank you, AJ. So I'll be talking about persistent storage a little bit now. So in previous versions of FuseML, we store some of the objects and the data in memory store, which means that every time that the FuseML core process was restarted, it would basically start without any of these data that were stored in memory. We can see here a basic representation of the data in FuseML core, and those purple objects were the ones that were stored in memory. We have project and code stored in Git, workflow run we store in Kubernetes, and runnables is under development. We just keep it stored in memory for now, but the real change comes from workflow assignment, workflow application, and extensions. Those were previously stored in memory, and now we are using BadgerDB, which is a key store database, key value store, and it's really lightweight database. easy to use it. You don't need a service to maintain a service running to use that database. It runs kind of embedded to the FuseML core binary. So that's one of the reasons that we choose BadgerDB to start those components. So with FuseML 0.2, you are safe to restart the FuseML core pod and everything will be saved, stored, and next time it starts again, you can see that you didn't lose any data. We can try it here. So we can see, I'm gonna list the workflows. So I have one workflow. I also have an assignment. An extension. Well, main 1, 2, 3, 4 extensions, and they also have applications. So you can see that I have basically all those components that were stored in memory before. And now we're gonna go and restart the FuseML core pod. And we can see that we didn't lose anything. Everything here should be back once it's restarted. So it just restarted. Let's list our workflow. So I have the workflow here, my assignments, my extensions, and also application. So with FuseML 0.2, basically we have all the data that we need saved in a persistent store, so we don't lose anything as it was on the previous versions of FuseML. I think that's basically it regarding storage, and I think I'll get back to Stefan to continue the community meeting.
Thank you, Flavio. Thank you, Ishi. So that covers installer extensions for third-party tools and the much needed persistent storage for the FuseML core service state. I could maybe add that you can, so as you've seen, you can use the installer extensions to create installation instructions for Kubernetes applications. So those are currently the only ones that are supported. And you can do that for your own tools. You can modify the tools that we currently provide through the extensions repository that Yoshi showed you. You can modify them to, I don't know, for example, use a different storage for MLflow or connect it to a cloud managed type of storage service, or anything that you can think of. Either you can start doing it yourself or ask us if we can help out. Reach out to Slack at any given time if you have any questions for us, or create issues in our GitHub repository. We are welcoming any kind of feedback that you have, any kind of request. We're going to use all these features. So it's maybe a preview of what's going to happen next. We're going to use all these newly acquired features around installation and extensions to extend FuseML, obviously, to extend FuseML with support for new tools. So we're targeting new tools, new machine learning tools for prediction, for training, and who knows, maybe even more. And you're going to see those in the next release, and you can use those to further enhance your machine learning MLOps workflows. Now I still don't see any questions in the chat, so either we've been really thorough or something else must be happening. And this would be the moment where we open to open the floor to questions. If you have any, don't hesitate to write them in the chat. We'll probably see them here and we can answer them. If you're watching this recording later, so rather than live, I guess you can reach out to our Slack channel, ask your questions there. You can find a link to the Slack channel in the FuseML. Yes, that's it.
Documentation, yeah.
Documentation, thank you.
I will say that if there are no further questions, I think that the community meeting number 2 of FuseML could basically consider over. Thank you all for the great work so far, and I really, really hope those that will watch this recording will be happy to join us and contribute to this great project. And with that, guys, thank you again. Have a great day, everyone that is watching us.
Thank you.